Hi, welcome to Regression Analysis lecture. This is one of the subjects in the Statistical Science Study Program, Department of Mathematics, University of Indonesia. So, what are we going to learn now? Um, we will be discussing about the variable selection, particularly the stepwise procedure. In the previous video, we've learned about kind of like the procedure on how to do the backward elimination, forward selection, and stepwise procedure. So for this opportunity, we will try to implement these methods in R. Okay, so as we discussed before, that the stepwise is kind of like a combination of backward elimination and forward selection. So we will again start with the backward elimination and forward selection before proceeding to the stepwise procedure. Okay, so we will just go directly to the R. So actually I've created like a hypothetical data on how to do the for this illustration of the variable selection. Okay, so this is the data that I've created. It consists of five independent variables, x1 up to x5, and one of the response variable y. Okay, if you want to know how many data that we have in this, we have 106. The dimension means that 100 observations and 6 variables. Okay, now like what have been explained in the previous video, we will start with the backward elimination. So for the backward elimination, actually we start with the full model. Okay, so I will fit the full model here. That is, I put this syntax means that take all the variables in this database and the y variable as the response. Okay, if we look at the summary of the model, we got this result. And then based on the algorithm of the backward elimination is that we eliminate the variable one by one, starting with the most non-significant one. And then we base our decision based on the t-value or the corresponding p-value. And in here, we see that the one that with the smallest t-value in an absolute value, of course, is that here, minus 0.096, or you can see the corresponding p-value is so high. So then for our first step, we will just eliminate x4 from our model. And how to do that? Okay, here instead of taking all the variables, we just take x1, x2, x3, and x5. Okay, we remove the x4. And then we refit the model, and then we see the resulting output. And here we see again we repeated the procedure, and we see that okay, seems like x3 should be excluded now because it has the smallest t-value or equivalently the corresponding non-significant p-value. So then again we need to eliminate that x3 from our model, and then we refit it, and then we look at the summary again. And here we see that okay, now all are significant. So even though you see that this t-value is smallest, but then still it is still contributing significantly in the model. So at this step, we will just stop here because all the variables that included in the model is already significant. Okay, maybe you might ask, why do we need to do it all over again? I mean that why don't just, for example, like from the full model here, oops, okay, why don't we just eliminate just x3 and x4 all together at the same time? Okay, the answer is that because, when we exclude, for example, just x4, there is a possibility that x3 could become an important variable, because the estimate parameters usually will change when the combination of variables included in the model is changed. Okay, so that's why we need to do it in step by step. Okay, so this is our final model based on the backward elimination procedure. This is kind of like we do it manually, but actually in R, there is the we can do that automatically using this step function and with the direction backward. Okay, but we have to start with the full model. So if we run this code, we will get the same result here. Okay, so we just need this one line of code to do the backward elimination. Okay, so that's about the backward elimination. And next, for the second implementation, we will try to do the forward selection. Okay, so like what has been explained in the previous video again, while the backward elimination started with full model, for the forward selection, we start off with the null model. That is the model that contains only intercept, and this is how we fit the model. Okay, so it contains only the what is it? The intercept. Okay, and then we need to do, we add one variable at a time. So for the first step, which variable should be added? Choose the one that is the most important one, and then the most important one is based on the t-value here. So it means that we have to run the model one by one. For example, if based on x1, then this is the t-value is minus 11.823. If we try x2, then we have the t-value is minus 4.495. If we use x3, then we have that value is 0.518, and like that, and so on. If you use x4, the t value is like this. If we use x5, then the t value is like this. Okay, and then we compare those 5 t values, and then we choose the one with the highest t value, of course, in an absolute value. But then it's kind of like not really efficient doing it this way, so we'll try to do it not really that manually. So we try to do some kind of looping here. Let's say here is that kp is the dimension of the our data set. Okay, the second dimension is that the number of columns, and then we subtract by 1. That is because, what is it? Let's say here we have that one column is for the response variable. So we just want to have for all the independent variables. So we take away 1 from the column, and then we will provide a place to store our t value and p value in here. So for x1, x2, x3, x4, and x5. Okay, so this is how we put it, and then we will run just like what we did before, and then here the ith row the first column here is for the t-value for this variable, and then the second column is that for the p-value of this variable. Okay, so then here, okay, here 2, I put the value 2 because, for example, like what is it, let's say, where is the full model before full model here. Okay, so then if we want to check the coefficient, okay, just or just here, it will give us this value because this is on the second, and then if I tried to put it on the third, okay, on the first place is always for the intercept, and then as we go along later, okay, I will just put it like, or just put it like this. Okay, so let's try to run it. Okay, so let's try to run this. Okay, so there we go. Because we just need the absolute value of the t, so that's why we just take the positive value here, and then we can see the one with the largest t value is the first one, that is x1. So our decision from this is the first step. Our decision is that include x1. Okay, so then here we do it again. Okay, we do it again, and now, so x1 should be excluded from the what is it, the options, because we already put in here x1 plus something else. Okay, so then x1 excluded in here, and then here now it's already, now it's x1, so intercept x1, and then it should be, now we are looking for the new edit variable, and then let's see, oopsie, there's an error. Let's see what happens in here. Da 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 p. Okay, so we have that, and then we have x1. Yeah, let's see what's wrong. Okay, oh yeah, because here we need to change another problem. We need to change our data. Okay, so here we have that the data is, now we have the new data. Let's say the f2 is the f, and then we exclude the we exclude x1. Okay, so x1 is in the first column, so that's why we exclude that one, and then here should be on data df2. Okay, let's see how it goes. Yep, so in here we know that, okay, the second variable to be included look at the highest t value but still significant here, so we think that the fourth column. And what is the fourth column of that data set? Let's see here, so is the x5. Okay, so our decision now is that, okay, our decision is include x1 and x5. Okay, and then in here it means that we also exclude x1 and x5 from the data set. Okay, so here x1 and x5 is excluded, so this one also take away one more because we already put x5, included it in the model, and then here already beta naught on the first place, and then coefficient for x1 on the second, x5 on the third, so we need on the fourth here. Okay, and then we run it again, and then here we go, we get that okay, since the first column is what is it, with the largest t, and still significant, so we should include it in the model. And what is it in the first column? It seems that it is the x2. So our decision, now we just copy it again. Okay, and then so our decision is include x1, x5, and x2. Okay, so it means that here x2 also excluded from the data set, and then here we only have 2 left, and then here we include x2 in the model, and then now we want to get to uh, the quantities for the new variables added in the model. Okay, now we run it again, and then we see, okay, the t values are all small, and then also the p values are not significant at the alpha point of 5. It means that no more variables should be included in the model. Okay, so then the procedure for forward selection stops here, and then so our final model is this one. Okay, this is our final, we can say maybe best model from our for our data. Okay, and then um, the result of that model is given by this x1, x5, and x2, and we can see they are all significant. Okay, seems like, wow, it's kind of like messy here. Okay, how we do the forward selection, but then if we do it in R, actually there's in a mass package that we loaded the library before, so we can just do that by the step code in here, and then we say the direction is forward with the scope of this is the full model. Okay, the model with the whole variable independent variables, and then we start with a null model. Okay, so if we run it, then we got exactly the same result like what we did manually before. Okay, so that's how we do forward selection in the in R using this hypothetical data. Okay, so then the next one is the stepwise procedure. Okay, we've also learned the algorithm or how to do that procedure in the previous video, and as you can see that when we run the forward selection is kind of like a bit messy before, and stepwise is much what is it, taking more steps than the forward procedure, so then we will just, I won't be doing it manually, so we will just take in R, we do it something like this. Okay, so we start with the full model, and then we say the direction is both, means like, you know, forward backward. Remember the procedure that we learned in the previous video, and then let's see what's the result in here. Okay, so what it means by the full model here, if you just forgot, I just remind you here, this is our full model. Okay, so including all the variables, and then if we do it using the okay, I just start, okay, this is our null model, and then okay, based on the stepwise, this is the result. Okay, so we get x1, x2, and x5. This is the, I think that the result is exactly the same like with the forward, right? So for the forward model is the result like this. Maybe there's slightly difference in the coefficient, or maybe they are just exactly the same. Okay, 24.1972 minus 6 minus 5, 4 minus 6, 4 minus 5, 152. Yes, exactly the same from the stepwise, and then from the forward. What about from the backward? I think it's exactly the same. Okay, in this case, in this example, yep, we have exactly the same result. Okay, so that's how we do what is it, forward selection or backward elimination and stepwise procedure in R.